Recently, I was watching the Disney movie Encanto, and during this scene, I thought to myself, you could totally measure the time it takes for that rock to fall down and calculate how many steps she had to climb to get there. I looked online to see if anyone else had the same weird thought, and to my surprise they did. I found a Reddit post by the user MellowMatt that asked this exact question, but there were no real answers to be found in the comments, so I took up the challenge, and this is the result. First, we need to know how long the rock was falling for. I took my trusty timer, and after some frame-perfect measuring, I came to a duration of 7.34 seconds. The next step is to completely ignore air resistance. We do this for a couple of reasons. I don't know the weight or shape of the rock, nor the air density, so I would have had to make a very inaccurate estimate. Additionally, the rock looks heavy enough to slow down the increase of air resistance while it speeds up. And last but certainly not least, I'm an engineering student, so I'm way too lazy to actually calculate it. Now we've got that out of the way, let's get on with the calculation. As the only force working on the boulder is gravity, we know that the acceleration is a constant 9.8 meters per second squared. To get from this to the distance traveled, we use a formula of what's called uniformly accelerated motion, which gives us this. In this formula, s is the distance we want to calculate. S0 is the distance we start at, for which we take 0. V0 is the starting velocity, which is also 0 in this case. AC is the constant acceleration, so we can fill in the gravity for that one. And finally, t is the time for which we want to know the distance, which in our case is the one we measured, 7.34 seconds. Thus, the distance from the top to the bottom of this pit is 264 meters. That is almost as high as 3 Statues of Liberty stacked on top of each other, including the pedestal. At this point, I noticed there was something weird about all this. Where did the rock actually land? Upon closer inspection of the different views, I saw there was a huge discontinuity with the room. Where did this big hunk of rock come from all of a sudden? It wasn't there just a moment ago. I guess we could just write it off as a magic staircase, as it's clearly a magical room fitting inside a smaller house. But that being said, we still have those stairs to calculate. To know how many steps it takes to climb this high, we need to know how tall the steps are on average, so we'll have to compare them to a length we know. On a magical place called the Internet, I found this wiki, which claims Mirabel's height is 5'2". Converted to SI units, that is 1.57 meters. The movie gives us this perfect side view shot in which we can compare Mirabel's height to the height of the steps. Using these two shots as a sample, we find that the average height of a single step is 21 centimeters. The total height divided by the height per step gives us 1,257 steps to reach the top. That's quite a lot.
A lot of stairs.
To use the same example again, that's about 3.5 times the amount of steps in the Statue of Liberty. What the hell, Bruno? Why? Silly questions like that aside, I was still wondering how long it took Mirabel to get to the top, as she starts off gracefully but slows down throughout the climb. If we assume that each of these 3 scenes represent a third of the way, we get a speed of 3 steps per second for the first scene, 2 for the second, and 0.8 for the third. On average, this gives a speed of 1.93 steps per second. Thus, for the whole climb, it would have taken Mirabel 10 minutes and 51 seconds, which is honestly less than I expected. But then again, 2 steps per second is pretty fast. So the conclusion of this video is, Mirabel is in great shape, and Anakin would hate Bruno.
I don't like sand. It's coarse and rough and irritating, and it gets everywhere.